Okay, we are starting in on our final little lesson on equation solving. By the end of this lesson, we will have touched on everything that you see in Math 053. Not every single type of question that can possibly come up, obviously, but every main concept. Um, and as I have been saying, the second lessons in each of our classes are, at least for the last few weeks, are really focused on the 053 material, and I've been making the first lessons things that also apply for 038 and 052. So in this lesson, you will not be required to do much, if any, of this kind of manipulation in 038 or 052. Maybe just a really basic. And Math 02 students, this is well beyond anything that you are going to see for any time soon until you, at least till you get to 053. So what we want to do now, this is working with formulas part 3. And so far, in all the questions, we have been given the values for all the variables except for one, whether it was the variable on the left-hand side that we wanted, and so we just needed to plug in, or if it was one of the variables on the right-hand side that we wanted, and we had to do a little bit of equation solving. The common theme of all of them is that we were given all of the variables. So what that meant is that we could just plug in all the numbers and isolate the one we didn't know. What's going to happen now is that we're going to look at questions where we don't know any of the values. But even though we don't actually know any of the values, that we can still follow through all of the same steps and isolate any variable in that equation, in that formula, to get it by itself. And there's various reasons why that's useful. We'll talk maybe a little bit more once we've seen one or two of these, how that could possibly be a helpful thing to do, but it is extremely helpful, especially in the sciences. But I'm thinking of finance courses I've taken where we also had to do this sort of stuff, so it comes up in various places. Yeah, that's okay. That's what I say right there. It comes up in all kinds of different courses that you might end up in, whether you're going into the sciences or finance, economics. A lot of programs require a statistics course. Business certainly does. Nursing does, because you have to be able to understand the results of research. For example, for nursing, scientific studies that are published. For example, so this is skills that you are gonna need likely in future courses. All right, so here we go. We're going to start really simple. The volume of a box is given by V equals LWH, and we have been asked to solve the formula for H. Notice they haven't told us any of the values, just isolate H in that formula. So the trick to doing these is just to imagine what you would do if you didn't know the numbers. If instead of those being letters, they were numbers, how would you make them go away? How would you get the H by itself and do the same thing? So what we notice here is that the L and the W are connected to the H by multiplication, and H is the thing we want to get by itself. Well, how do we get rid of multiplication? By dividing, right? So the opposite of multiplying by L and W is to divide by L and W. So there's our equation, V equals LWH. And we say, I want to get the H by itself. So we have the H is being multiplied by L and W. The opposite of multiplication is division. So dividing by L and W is how we will make those go away. So we're going to divide both sides by LW. You could do it one at a time, but you might as well do them both together. Why? Because they both then cancel out, and we get H all by itself on the right-hand side, which is exactly what we've been asked to do. What do we have on the left side? V over LW. I want you to notice that in some ways these questions are actually easier, right? Because you don't need to now plug in a bunch of numbers and see what is, this number divided by those numbers multiplied by each other and calculate the H. You just move the pieces around and you get your answer. So the formula solved for H is H equals V over LW. And where could this possibly be useful? Well, one of the main ones would be, let's say you're doing some experiment where you measure the volume and the length and the width, and you need to calculate the height that goes with it. I mean, it's a fairly simplistic equation, but let's just imagine. Well, instead of then every single time plugging in the V, the L, and the H, and then isolating the H, now you have a formula for the height where you just plug in your numbers over and over and over instead of going through all the equation solving steps every single time. That's probably the main use of this. If you say, you know what, this would be a lot more handy, this formula, if I had the H isolated instead of having the V isolated, and then I can just plug my numbers in. So here's another one. This is actually various. If you look at the formula, this is now talking about interest rather than volume, but really it's the same formula essentially, right? V equals LWH, something equals three things multiplied. I equals PRT, something equals three things multiplied. And we've run into this equation once or twice before in our practice. So we've been asked to solve this formula for R. Now, what I'm going to remind myself here, you see the R is stuck in the middle there, but remember that if three things are being multiplied, the order that you multiply them in doesn't matter. So I could easily just switch that R and that T. Sorry. And that's the same equation. P times R times T is the same as P times T times R. And now I've actually made it exactly like the last one. Yeah, it's exactly the same as the last one now. So I divide both sides by P and T because they both cancel out, which leaves the R by itself, which is exactly what we were trying to do. What's now on the other side? I divided by PT. And so this equation, isolated for R, is I over PT. And this would be maybe handy if you want to calculate what rate of interest you need in order to achieve certain goals. You say, well, if I want to earn such and such interest with the money and time I have, and you could, or maybe you have a bunch of different scenarios you want to check out. And so instead of solving the equation for R every single time, putting in the new numbers, solving for R, putting in new numbers, solving for R, now you have an equation for R, you just plug the numbers in and calculate. Formula for the area of a triangle, A equals 1/2 BH. We have been asked to solve this for B. Okay, so let's write the formula. Now we want to get the B by itself. Yeah, so there's a couple different ways to go here. You could say, well, the half is attached by multiplication and divide both sides by a half. That's generally discouraged. While technically not incorrect, we don't like fractions inside of fractions because that would create a half on the bottom underneath the A on the left-hand side. We don't like to have fractions inside fractions because it's messy, it's hard to deal with, it's difficult to calculate when later on you're plugging in values. So a much simpler option would be to get rid of that half is to multiply both sides by 2, which, pause and think, is the same thing, right? What is dividing by a half? It's multiplying by the reciprocal, multiplying by 2 over 1. 2. Okay, so I would suggest the easiest way to go on this, not the only way, but the easiest way is to multiply both sides by 2. Because we remember that that is 2 over 1 and goodbye fraction on the right-hand side. The 2's cancel. And all we have left now is BH. And on the left we have 2A, 2 times A. Okay, so that got rid of the fraction that we didn't like. Next, we want to solve for B. Well, right now B is being multiplied by H. So I make that go away by dividing by H because the H's cancel out on the right, leaving just B. And on the left, just write down exactly what we have there, 2A over H. So there is that formula solved for B. If I were to give you various areas and heights of triangles and ask you to calculate the base, you could just plug them into that new formula that we have created there, isolated for B. Andre's selling necklaces at a craft fair. He earns $30 per necklace, but he has to pay $500 to get that table at the fair. That's, by the way, pretty standard practice how those things work. You buy a table. You don't actually buy the table, but you buy the right to set your stuff up on a table at the craft fair, and then you sell your stuff and hope that you make more money than you had to pay for your table. So Andre's profit is given by the equation P equals 30N minus 500. In future courses or even future chapters, you might be asked to come up with that equation on your own from the word problem, but that's not going to happen right now. They're just giving you the equation, where N is the number of necklaces he sells. Solve the equation for N. Okay, well, let's write that equation down. Let's see. Well, this looks like a two-step equation, right? We have the piece with the variable and a constant piece. Now over here, this is also a variable, but in this context, it's a variable that we don't care about, right? Because N is the one we've been asked to isolate. So it's as good as being a number, that P is. That's how we're going to treat it. So I got to make that constant term go away first. Subtracted 500 on the right becomes an added 500 on the left. Now I've got a 30 being multiplied. What is the opposite of multiplied by 30? It is divided by 30. But whatever we do to one side, now listen, we must do to the entire other side, which we can write like that. We can also separate those out, P over 30 and 500 over 30. There will be situations where that's the most useful thing to do, but this is not that situation. In this situation, what you want to do is almost always divide that entire left side by 30, like we've shown it there. The 30s cancel, meaning the N is now all by itself, which was the whole point. And don't try and do anything with that left side. We don't know what P is. Some people, here, this is important. Some people are tempted to reduce the 500 and the 30, but you can't because the top has more pieces in it. So that's an important thing to remember. You cannot cancel part of the fraction on the top and bottom. If there's multiple added or subtracted pieces, you'd have to be able to reduce all of them. And that's actually a pretty common little mistake that people will make. They'll reduce when it doesn't apply because there's the technical way to say it is multiple terms in the either numerator or the denominator. So we've solved the formula for N. And what can we do here with this? Why might Andre want to do this? Well, now say he wants to imagine different amounts of profit that he's hoping to make. Is it going to be worth my while to go to the craft fair? What if it's only worth my while if I make $1,000? Put 1,000 in for peak. How many necklaces would I have to sell? Quick to calculate. Maybe Andre wants to try that with a bunch of different profits. It's how many necklaces would I have to sell? So instead of plugging in P over and over and over and solving the equation over and over and over, you now have a single formula that tells you how many necklaces Andre has to sell to achieve a certain profit. Okay, getting bigger here. Surface area of a cylinder given by the formula A equals pi r squared plus 2 pi RH. And we want to isolate H in that formula there. Now, if I had said isolate R, this would be a very hard question. You wouldn't be able to do that until grade 11 math, at least math 07 something. And even then, I don't think they'd ask you to do it in this context. That's more like a university, something you'd run into in math or physics in university. But isolating H isn't too bad because there's only one H there. So we want to get the H by itself. What is with it? Well, this is really just a two-step equation because we have something being multiplied by H. Who cares that we don't know what it is, right? There's something being multiplied by H. I have a feeling I highlight that. Yeah, there we go. We have the 2 pi r being multiplied by H. And then we have a constant term. Now, there's an R in it, so in that sense, it's not a constant term. But in terms of isolating H, the pi r squared is just like a constant term. It doesn't have any h's in it, right? So that's what we got to deal with first. That is being added, which we are too lazy to write, but remind ourselves there's actually a plus sign in front of that term if we haven't written it. So that added pi r squared on the right becomes a subtracted pi r squared on the left. But meanwhile, this multiplied 2 pi r, we get rid of that, not with subtracting, but with dividing. So I'm going to divide the entire right side by 2 pi r, which means I have to do the same thing to the left, the entire left side. Why did I do that? Because that just cancels out completely on the right, leaving behind h, which is our whole goal. And on the left is just what's on the left. We don't know any numbers, so we can't do any more work on that. We can't calculate anything there, right? We just leave it like that. And again, don't be tempted to cancel. Like the pi's might look like they cancel, but the top has multiple terms. It has terms, by the way, if you haven't run into this yet, are all the pieces separated by adding and subtracting. So this has 2 terms on the top, the a and the pi r squared, separated by subtraction. You cannot cancel if that pi is only in one of the terms. So there is our formula isolated for h. And again, maybe starting to see now how useful this could be, because this is a bit of a time-consuming equation to solve. So if you had a whole bunch of area and radius pairs, like the area is 500 and the radius is 6, find the height. The area of this one is 1,000 and the radius is 12, find the height. And you're doing that over and over and over, solving the equation every single time. Well, now instead, you've isolated h. You can just plug the numbers in and do the calculations way faster. Yeah, so we got one for you to try here. Now I've given you parts A and B, and this matches the type of question you will see in your book in 053 as well as definitely on your test. They have asked you to do 2 separate questions here. In the first one, they want you to put a 2 in for x. So you actually do know the numbers and then solve that equation for y just using our regular equation solving. And in part B, they want you to do what we've just been doing in these last examples. Leave the x as x, not as 2, and isolate the y for that equation in general. Give you 3 or 4 minutes to try those 2. Okay, so let's take a look at these. In the first one, we have the equation 3y minus 5x equals 6. We've been told to solve for y, in this case, given a value of x. So we've been told x is 2. So we replace the x with 2, like so. And now, well, what is 5 times 2? Let's work that out. It's 10, so 3y minus 10 equals 6. And we have our usual 2-step equation. We've got to get rid of the constant first. A subtracted 10 on the left becomes an added 10 on the right. 6 plus 10 is 16. And we divide both sides by 3 to get the y by itself. And we get 16 over 3. Fractions don't scare us. That's just a perfectly fine answer. Go read the instructions, and if they happen to say give your answer as a mixed number, 3 goes into 16 5 times with 1 left over, 5 1/3. Okay, so that's what we do if we've been given a value for x and we want to solve for y. What about when they say in general? What they mean is take that equation not knowing what x might be. So completely forget the fact that in part A they said x equals 2. I'll see people go through all levels of this question and suddenly throw a 2 in for x, including getting all the way to the end to the right answer and then putting a 2 in for x. No, in part B, x is not 2. They just want you to solve this equation for an unknown x value, just leaving the x in there. So we start with the equation again. There's nothing to sub in, so we skip the step where we sub in a value for x, but it's still a 2-step equation. We have the piece with the variable y that we're interested in, and essentially a constant term over here. We don't know what x is, so we don't know what that constant term is, but in terms of y, that's a constant term. So a subtracted 5x on the left becomes an added 5x on the right, knowing that what we actually just did without writing it down is we added 5x to both sides. Now we want to get the y by itself, so we divide by 3. I would like you to once again notice that even though this often feels a lot more confusing than when we know the numbers, it is actually easier to do these questions than it is to do the ones where we have the numbers. Look how many more steps it takes when we know what the numbers are. Then this, we just, add the 5x over to the right, divide both sides by 3, they cancel, leaving just y. Boom, just like that. 6 plus 5x over 3, again, do not be tempted to reduce the 6 and the 3, because there are 2 terms in the top, right? So if you want to reduce that 3, it would have to come out of both the 6 and the 5, but it doesn't come out of 5. So that is what they mean by when they say to solve for a variable in general. And again, don't just completely forget about part A where x was 2. In part B, x is not 2. You're just going to leave x as an unknown value. Oh, this is interesting though. If you did plug in x equals 2 to this new equation we've solved for y, 5 times 2 is 10, plus 6 is 16, 16 over 3, we get the same answer, right? So again, if you were in a situation where you had to create a big table listing 30 values of x and finding the y that goes with them, which is something you will be doing in Chapter 4, maybe not 30 of them, but several of them, then instead of doing all this equation solving every time, you just take all your values of x and plug them in one at a time and get quick answers. And that is the end. I'm going to go back one slide just to not confuse the issue by saying that x is 2, because again, in part B, x is not 2.